So welcome everybody, glad you could join us. I'm pretty excited about this because Go is a relatively new language for me. I've just really started experimenting with it, and I know that JFrog has been doing a lot of cool stuff with Go lately, so I wanted to bring Craig in to put together something interesting. And basically, I think it really boils down to two things. One, we wanted to figure out how we could speed things up, but on another plane, we wanted to figure out how we could also make things more secure. So we put together a little bit of content around that and a demo. And by we, I mean Craig. Craig did all the work, but then he showed up to share the work, and that was the critical thing. So to introduce Craig, and if you want to share your screen, sure, we can introduce ourselves. But I'm the chief evangelist for Codefresh, and mostly focused on containerization, continuous integration, continuous delivery, really CI/CD pipeline kind of stuff. And then Craig is actually the director of product at JFrog. So anything else you'd say to introduce yourself?
Sure. So my background is completely different than yours. I'm not a full stack developer. I'm learning Go too. My background is actually in statistical programming. And then for the last 15 years, I've been working on solving developer problems for distributed systems. Great. So this is actually a great thing for me because we decided to do this. I needed to learn Go myself. Oh, we took ourselves off the screen. Maybe you can see the little one. The t-shirt I'm wearing is actually JFrog one. If you do the Go challenge, you can win this t-shirt. I'll have the URL at the very end, so you can try that out if you want. It's actually cute. It's got a little boat with a frog and the gopher together.
Perfect. I want to win it myself. Okay. So let's see. I guess we should just jump in.
Let's do that. Thank you. So first I wanted to talk a little bit about JFrog and what role we play in the developer ecosystem to kind of kick things off and position it. So the reason I chose this slide is that it kind of illustrates the point. When working with Codefresh, and I think a lot of your audience are probably coming to Codefresh from a sort of cloud native applications perspective. Mm-hmm. What we talk about is how having a container registry is a necessary but not sufficient condition for having very operable applications in Kubernetes. So you need automation. Codefresh provides killer automation. You need a Docker registry. You need a Helm repo, and you need Kubernetes clusters. And Codefresh makes all of that stuff super manageable. Now, what you put into that Docker registry is really where Artifactory comes into play. So what this picture illustrates is that, kind of on the right-hand side, you've got your Helm definition of your application, you've got your Helm charts, and all the Docker images orchestrated in the pods. The thing is, when you deconstruct what's actually in the Docker image, it turns out it's composed of a bunch of sort of upstream packages. Sometimes there are operating system components that your app depends on. Often they're packages from your application development framework, whether they're Maven or NuGet or NPM. And today what we're going to do is look at Go modules. Then you package that up into your Docker image and publish that to your app. And so today we're going to focus very much on the left-hand side here. We're going to look at Go modules and how Artifactory works together with Go modules, and Codefresh can automate all of this process. For the demo today, we're kind of going to end at the Go module packaging thing. Going forward, we're going to build that out on this to show you the best practices for how you do that in Docker images and deploy those to your Kubernetes clusters. Okay. So Artifactory is this repository management platform that allows you to have a consistent way of managing all of these different kinds of packages that you use to build up your cloud native application. And it's this platform that's available both in the cloud as a SaaS service and on-prem, so that enterprises who want to have close control over their packages can do that.
Today, are we using the cloud version?
Today, what we're using is a cloud version,
okay.
Yes. Okay. In fact, it happens to be deployed in Azure, and we're going from that. So it's accessible via REST API, CLI, IDE plugins, the UI, which we're going to look at mostly today. Well, the UI and the CLI are the two things we're going to look at today. So that's enough about that. So let's talk a little bit about Go. Why are we here, right? So like I said, I come from a statistical programming background. I used to work a lot in R, SAS, Python, SPSS, those kinds of things. And then I learned C++ and Java and all these other things that have all these decorations and crazy ways of expressing things and lots of ways to shoot yourself in the foot. And very sophisticated and very difficult to use ways to do concurrency and multi-threading. Well, we've gotten to the point where multi-threading it should be just an innate thing. You shouldn't have to have all these decorations.
Yeah.
Well, Go is this new language that is natively concurrent and takes advantage of all of the hyper-threading capabilities of modern processors. So that's one of the things that we really love about Go, now that we're spending some time on it. The next thing is that networking is just assumed, right? Like you used to have to do all kinds of stuff to do that. Well, now it's just straightforward libraries that are built in to do all of very high performance capabilities of the basic stuff. You can obviously import code and depend upon other people's Go to do additional things. And that's great to add on top of it, but you've got all the things you really need to get going built in. The next thing is that for performance reasons, it's not an interpreted language. It's compiled from source. It's an executable that's specific to the hardware architecture. And so the compilers that's how you get this like native hyperthreading capability.
Yeah, that's one of the nice things about that is that I've noticed, and I think this is one of the reasons that Go is so popular with containerized applications, is that when you do compile from source, it really uses these streamlined sort of libraries. So the images you get are incredibly small. Whereas like if you want to say hello world in Java, like you're a gig into that thing, right? Like you're a gig into that image just to say hello, because it's going to pull in all the stuff and it's a whole stack of stuff. Go is so streamlined, and it's the builds can take a little while, but once you have the binary and the Docker image, it's so small and it runs incredibly fast. So it's very, very performant in that way.
Yeah, so somehow it's managed to balance that need to be slim and performant with reusability. So it's super easy to build your Go binaries for multiple platforms. So you get a lot of the benefits, and thanks to containerization, we can then move those binaries anywhere, and life is beautiful. One of the things I'm just loving about it is the syntax is just incredibly simple. Like you read it, what it says is what it does. Interpretation is by a human. It makes it much more maintainable code. Right? So that's been very attractive to me. And then the last thing is that the community around it. It sort of has grown up in this new cloud native way of doing things, and the community around it has been really welcoming and open.
Yeah, the Golang Twitter game is pretty strong. And we, of course, GopherCon was just a few weeks ago, and my friend came back from it, and I asked him how it was, and he said it was really boring. And that's actually the best thing you can hear about a language conference is we got through all the exciting problems, and now we just have some boring problems. And that's the moment when you know that it's come of age and it's ready for prime time. Is the conference was kind of boring. They did have cool stuff, by the way, but anyway.
I didn't get to go. JFrog was there, and I'll talk about that in a minute. So with all these great benefits, there's comes a couple of challenges. So when you're depending on somebody else's code in Go, and you're doing an import, it imports from a reference to a namespace, and that namespace gets resolved at build time, right? And so that namespace isn't under your control. Like as an enterprise developer, like as an enterprise company, that can be uncomfortable if those external resolutions aren't inside your company, right? So you don't know that somebody is not out there changing the code. Right. Maybe your code your build will break because somebody else makes a change to the code and it's not expressed in a version. So fundamentally, the question is, I got this thing working today, I got my build working today, I got my binaries tested today, but when I need to go make a change tomorrow, well, somebody else has made a change that breaks my code. And as the community of Go just explodes, the number of awesome things that you can and should use has just exploded along with it, right? So there's tons of extensions to languages and tools, libraries of all different kinds.
These are similar to the challenges we've had with like NPM, right?
Precisely. The challenge is that Go built natively didn't have a notion of packaging beyond the binary. By the philosophy of itself, it's about build to binary, right? And so the notion of import was explicitly about the code itself. And so in order to address that, over the last few years in the Go community, there have been various efforts to try to resolve this challenge, because as the community explodes and code reuse becomes a really big thing, lots of alternative approaches were proposed. There are at least 4 that I know of. And at JFrog, we've been involved in helping resolve the kind of controversy around the different kinds. And in fact, we're involved in the introduction of something called Go modules. It used to be called versioned Go. So the proposal was made several years ago for versioned Go. If you do search on the internet, you'll find a bunch of great proposals, blogs, discussions about versioned Go. So we put our weight behind that, and it landed in Go in version 1.11 just a couple of months ago, right?
Just a few weeks ago.
Well, I'm already thinking, I'm a product manager, so I'm always
you're thinking ahead.
I think it's 2019 already based on my planning work, right? But yeah, a month ago. And actually Artifactory introduced a private registry for it before it was actually natively supported in Go back in May. And so we've actually built robust support for it. And it turns out it's actually really easy to take an existing project and make it take advantage of modules. So what is a module? A module is a collection of packages. So these are these external dependencies that you're depending on. And they're downloaded. So you have a local copy of them, and they're basically tarred up and they're versioned. And so what this means is that you no longer have to go to some unknown source. Like a lot of Go modules, a lot of Go packages are on GitHub, but a lot of them aren't. People publish them anywhere they want, right? And so, dependency on GitHub is not a terrible thing. We in the open source community live with that all the time, but we also know that it's not always as fast as we want it to be. It's also under some, we're depending on somebody else's repo, so it's under their control, not ours.
Right, we want to validate it and put it into sort of a safe zone where we've done some security scanning or something to validate these modules and put them into a place where we feel comfortable that our team can pull them in.
Now, there's a lot of use cases around needing to know that you're getting exactly the same code that you got before. Reproducibility is one. You hit on another, security, assuring that we're using the same code that we did the security test on before. There's also brain went off the track there. There's a bunch of use cases for that, and so you want to then be able to govern those things, and that's exactly the value that
maybe traceability is one of the things, like auditability.
Auditability is exactly.
Okay, I know it was there. I know it was there at this time. I know it was there in the next build.
Yeah, exactly. And so to get started, it's actually super easy. Once you have Go version 1.11, you get into your project. You run Go mod in it, and that will actually create a new file called go.mod. What it does is it's just a placeholder for the beginning, and then you run go mod tidy. And what that will do is that will traverse your code and look for all of the imports and all of their transitive dependencies. So it builds this file up, and then Artifactory uses that file as an index to then go and understand how to go get those code and then create the modules itself and store them in Artifactory. So let's take a look at what that kind of workflow looks like. So we'll get right to the point and get into the demo. So on day one, you start your project, you've done your go mod tidy, and if you're working with Artifactory, then what happens is you're trying to do your build. The build goes to Artifactory to try to find the modules. It doesn't have them, and it kind of complains a little bit. I don't have a local copy, so what do? So in step 2, what we do is we do it the old way. I go directly to GitHub repo where the module is, or wherever those modules are, or wherever those packages are. I pull those packages back, and then I package them up and I push them. I publish them to Artifactory, and then what happens then is that everything is sort of, all the dependencies then get stored in Artifactory. I understand I have traceability between one build and all of its transitive dependencies. And then let's just say another developer, this is another use case for why you would do this, is another developer wants to make sure they can do the same thing and depend on exactly the same packages. Well, it turns out if they're all locally resolved inside Artifactory, you don't have to go outside. You don't have to go to the outside world. This is very important for use of a language like Go in a lot of enterprise kind of environments. You know, it has other benefits for non-enterprise, but clearly there's an enterprise benefit there. So, what I want to do in the demo is I want to say, well, let's marry that to Codefresh. Like, we could do all that with Artifactory in the command line, and that's what I did. And I said, well, let's put all of that into Codefresh and show how we can do fast, safe delivery of these Go packages in the cloud using that. So that's really where I want to go. Does that make sense? Jump into the demo now?
Yeah, no, that's great. So just to introduce Codefresh as you pull it open here, for those that aren't familiar with it, Codefresh is a CI/CD platform designed specifically for the world of containers. So we have built-in steps for doing things like building Docker images, for doing advanced deployments, blue-green, canary deployments into Kubernetes. And then, as Craig mentioned, we have some really great integrations with JFrog, where you can use Artifactory as your Docker registry, your Helm repository. And that kind of goes to our philosophy, is that we really want to be an end-to-end. We got your commit over here, and we got your deployment environment over here, and we want to glue all this stuff in between, or weld, I don't know, a better metaphor. So here we're looking at all our repositories.
My repositories.
All of your repositories, and we've got that going. All right.
Yeah. So I'll just step through sort of what I did. The first thing I did is I created a project that Dan makes fun of the name of it, where what I do is I'm building a Docker image to reuse to be the glue between Codefresh and Artifactory. So what this glue is it actually uses the JFrog CLI, and what I've done is I've baked it into a Docker image that's just stored here locally, so that I've got my my local image to use over and over again, so that my builds go super fast. Right? I don't have to download all the tools I need. And then what I have is I have this project. It's a GitHub project actually, and so let's take a look at the GitHub project. I just forked one of Dan's projects that he uses to demo Go and Codefresh.
That's what I use to demo Canary
deployments,
and especially with Istio, yeah.
Exactly, and that's a killer webinar if you want to go back and check that out. But what I did was I just did exactly what I told you. I did go mod init, and then go mod tidy, and pulled in the dependencies. It turns out that the way in which he had written it, it had no external dependencies whatsoever. So that wasn't very interesting. So I hacked into it a couple of dependencies. And what those dependencies do are just put a quote into his little boxes. So it uses a library here called rsc.io quote. So here's an example of pulling a package from a non-GitHub repo. And when it did the build, it put it into Artifactory. So let's take a look at the most recent build, and we'll kick another one off here in a second. So the most recent build is here. So what I can see here is that in the modules that got published by Codefresh, it creates the mod file. Obviously, it's versioned, the semantic versioning, and there's a zip file that contains all of the contents of that. And then I can see here's the direct dependency I had, which was RSC quote version 1.52, and it has both a zip and a mod. So we've taken that transitive dependency, we packaged it up, and we shoved it into Artifactory, and I can actually go and find that module in Artifactory and see, Artifactory understands the structure of these things, but this is now in my local Go repository. So what I'm going to do is I'm going to make a small change to the code. I'm going to kick off a build, and then we'll take a look at how that works. So I'm going to do very bad style here. I've pre-staged this new dependency. I'm going to pull out this quote, or this comment. There's no reason to have it. I'm going to uncomment the other lines that just do some trivial use of that package so I don't get a Go build error. And then I'm going to say I added this new RQ dependency. So let's commit those changes. And then what happens? Well, magically, of course, it's not magic because Codefresh understands the notion of the git commit. So it uses the git hook. And now I see my my new commit here, and it's kicking off a build process. So in Codefresh, it's got this really nice new UI that they just added, where I can visually see what are all the steps. So I'm going to dig down just a little bit into the steps and the code themselves. So what's going to happen is, just like I showed in the slides, it's trying to do a build resolving that new dependency. And if we go in here, we're actually going to see that there's an expected error. Remember, I went to try to go to Artifactory. It couldn't resolve this new dependency because it didn't exist in Artifactory, right? And so, let's see, where is it exactly? So it couldn't find it. So what it's doing now is Artifactory is actually going and creating the new build. It pulled down all the packages, rebuilt them, and published them into Artifactory. And well, it published the dependencies into Artifactory, and now we're going to go and publish the build. And then finally, in my steps, just kind of for nicety, I create the binary executables from Go, and I publish them into Artifactory using this great tool called Go Releaser. So what it's doing is it's creating this new build. So if I go here and look at the builds, I'll now see this new build that now has new dependencies. Right. So here you can see it's got additional dependencies on this DDO library. So now I've got a local copy. Somebody else goes and uses that same library. I know that they're going to be able to resolve exactly the same package of it that I use. Yeah. So what does that look like kind of in the repository? So here I can see my local repo. It's now created this this new package in it's in the GitHub.com namespace, just like mine is. But I've got my new Go build here. So Artifactory now has that set up, and that was actually really easy to do with Codefresh. So let's take a look at what that build looks like. So what I did is I did it in Codefresh YAML, because it's actually a very straightforward way in which to express this logic. So what I did is I kind of said 3 stages, because we have to go through all the steps. So the first stage tries to do the naive build. If there are no new dependencies, or all the dependencies are resolved from Artifactory, then it sets this variable. Yeah, all the modules existed. That's great. What happens is that it checks this next step. It says, well, if the mods all exist are true, are not true, if that's not true, then you have to do this step, which means you have to download all the packages from source, you have to build them up, and then publish them to the repo. Otherwise, let's do all the build, let's collect all the environment variables, let's then publish all of these modules to Artifactory and all the dependency information, and then, oh, why is it not scrolling? Let's take a look.
Now, one of the things that makes this unique, and I mean, for people that are new to Codefresh YAML, each of these steps is its own container. Yes. And so the way that we basically built this sort of integration is we just built a Docker image that had the JFrog CLI and the Go tooling built into it. And then here you can see that we're actually referencing it. It says Go binary build info publish, and then it specifies the image. It says, this is the image I want to run in this container to execute these commands. And then the commands are laid out here. And so very easy to build that. And if we were going to make this like a generic step that other people on our teams could use, we could actually basically script this and put it into the image itself and set that script as the entry point, at which point people would just maybe pass in, a variable that they needed, and they wouldn't have all the commands. They would just have, this is the image that does this step, and it's reusable. Anybody can grab it, and it's on the rails and set, ready to go.
Yeah, so I think that's what we need to do next.
Yeah, that should be the next thing we do.
Yeah, absolutely. And then obviously in this case, I'm simply publishing all the modules into Artifactory. And the last step I'm doing is I'm actually uploading the binaries into a generic repo in Artifactory. So what that looks like is the binary release local is where I'm putting them. So in here I can find, say, I want to download it for my platform. So these are the most recent build. I can go do this. I can download it. Obviously, now what I've got is the tar.gz. I unzip that. I take a look at that on my Mac. What I see is here's my binary and the README file. It goes right along with that. So I've simply automated the process of making a change in the Git repo and automatically resolving all of the dependencies that are already local, and then uploading them into Artifactory.
Yeah, and we could add tasks that would happen before it goes up, such as tests or security scans. We could even do performance tests on these things, and we could basically set those all as gatekeepers into Artifactory to say, it can't go to Artifactory unless it passes these checks.
Absolutely.
That would be set here.
Absolutely. So I think what we've done is we've kind of illustrated the principle, which is that you can make your builds reproducible. We now have a local representation of all of my builds, and as well as a cache of all of my artifacts that are versioned in a semantic way using this new Go module capability, and done it in a very straightforward way that's easy to understand and easy to maintain.
Now, this gives us the sort of reproducibility. It does give us that traceability and kind of auditability stuff. For performance, depending on your setup, you'll see different performance impacts, and in most cases, you would see a slight speed up now that we've done this. To take it further, we could actually add in some caching. So if we want to go back to the slides, I think I have one or two on this after the demo, and then move to the Q&A. So we can actually speed this up further using some kind of Codefresh build optimization. Some of this is sort of automatic, but when it comes to Go, there's maybe an additional step that we would take. So to do that, first, just to understand why this is going to work, you have to understand that every step is its own container. Now, what we do at Codefresh is we automatically attach a build volume to your pipeline every time. And for those that are Kubernetes people and are interested in how this works under the covers, basically we create a persistent volume claim for every pipeline. So when we rerun the pipeline, we remount that volume into each container so that the cache is actually available. So in order to, now this is useful for a couple of reasons. In the pipeline that you just did, you had a step that checked dependencies and it wrote a variable. Where did that variable go? It went to the build volume. And then in the next step, it can look at that variable and say, hey, are the modules there or not? And the variable tells it, no, they're not here.
I was wondering about the persistence between the steps.
Yeah, so it's persistence between steps.
But there are also the CF export essentially writes variables to a temporary file that's stored on the volume. Well, it's not a temporary file.
You set it in the Codefresh volume path, right? And there's a variable for that.
Got it.
So the next thing you can do to actually speed this up further is we can use the CF volume path as our Go path. Now, what that will do is basically it'll download all of the modules onto that volume that is persistent. And the next time it runs, the first thing it will do is it will say, it'll basically looking at this, first it'll look at the build volume and say, hey, are there modules here? And it will say, if they're not there, it'll say, oh, they're not here locally in the volume. We need to pull them. Then it will look at Artifactory and say, hey, are the modules in my Go, what do you call it, a Go module repo? My Go module repo. And then if they're not there, then it will go further into the source and actually pull and then build from scratch. But once it's done that, it's now sitting in the build volume and it's now sitting in Artifactory. So This gives this will give a pretty big performance boost. I think our build time on that was like 1:19, so it really was very, very quick. We could probably shave 30 seconds off of that by setting the build volume here. And depending on your particular build, this app is very, very simple.
Yeah, super simple. You get much bigger savings on a complex app.
Yes, on a complex app, you'll get much, much bigger
I
savings.
actually want to try it on our CLI, which is a moderately complex Go app.
Oh yeah, let's hack that out after the webinar. Maybe we'll live tweet that or something.
That sounds like fun.
So that's what we would do to go another step further and actually speed these up further. And it basically is like taking it's not like a pre-compiled binary, but you eliminate all of the networking overhead that you would have in this.
Well, you actually get all the beauty of what is Go, because what is a module? A module is actually, frankly, it's a tar-gz that has semantic versioning of the source code itself. And so it doesn't break anything about the way in which Go works, while it takes advantage of all of this intelligence, caching, and semantic versioning of modules in the system itself. So it's a beautiful marriage.
Yeah, great. So now we can move into the Q&A portion. So someone asked, what is the advantage of getting a Go mod from JFrog compared to fetching it from GitHub? Other users can also just browse GitHub and find other modules, right? Also within a big organization.
That's absolutely true. The challenge that you have in a big organization is one of control, right? So if you're browsing GitHub for packages, the owner of the repository where those packages are is the one in control of those modules. Now, if that's your own private repository, and you're using, say, GitHub Enterprise, then obviously you can optimize things there. But it doesn't take advantage of the semantic versioning of the modules and the local caching of those in Artifactory and or in the Codefresh volume.
Yeah, and
volume clean.
Yeah, and you even if you're browsing GitHub and like the stuff that you control versus the stuff that other people can control, that makes a big difference, right? Because if someone else is controlling that Go module and you're just always pulling from that external source, maybe you haven't vetted it, maybe there's some sort of process you might want to go through.
Well, it really depends on your organization whether or not that matters, right? And so in companies where they need to put in place a vetting process over external dependencies, this is an absolutely critical step. In organizations that don't do that kind of vetting, then it's somewhat less interesting.
Yeah,
it's still valuable from a reproducibility perspective, because you've essentially got the tar-gz of the code. So if some change happens out of your control on that source, whether it's GitHub or somewhere else, then you can still reproduce it. That turns out that's very important for auditability.
Yeah, well, and I mean, the final step of this would generally be that we actually build a Docker image, which we didn't do here, but the Docker image would also be persistent here, both within Codefresh and Artifactory, so we could actually pull that Docker image to get that as well. Emmanuel asks, in which Artifactory version is the go.mod supported? I'm using 6.10. The latest version is 6.3.3.
Yes, that was in my slide. Oh, I'm in presentation mode.
I believe it's
I can't remember off the top of my head.
The more recent one.
So we had introduced it in May, and so it's in versions. Oh, what is the version of that? That would have been. Let me look it up.
While you're looking up, and this is limited to Go 1.11, and Go 1.11 is new enough that it actually hasn't even made it into like apt-get yet. Like it's not in the normal package manager. So we actually had to, when we built the Docker image, we actually had to install from source. We couldn't use the package manager to do it. So it will. I mean, it's sort of cutting edge stuff, right? It's in the latest release. So if you're not using 1.11 Go anyway, you won't have the option.
Well, there was another way to work around, which was an app plugin for Go that enabled version Go prior to that, but it was it's more clunky to use. Having it in the base Go is huge advantage. The version of Artifactory in which the Go private repos was introduced was 5.11.
Oh, so
May of 2018.
So Emmanuel should have this
Correct.
available.
So it could be a permissions issue, or an admin. If you don't see it, then talk to your administrator.
Okay. So Emmanuel, feel free to reach out through the chat. We'll see if we can help out with that.
Absolutely.
Tom asks, when I pull a third-party package down from GitHub and load it into Artifactory, does the version number match a version the original author supplied? Or is it a version number only in my local Artifactory? So
the version number is if the package uses modules, the publisher of that module will have provided a semantic version for it, right? In which case, we've seen that in Artifactory, it is bound to the version that the publisher of the package describes it as.
Got it. So it doesn't matter that you've pulled it into Artifactory. In other words,
we don't somehow change the version number. No,
yeah.
We use the version number of the package of the module as it's defined by the owner of that package.
This reminds me, one of the things that we did here, which I think is a best practice, is that we report from Codefresh the build ID to JFrog. And instead of actually reporting a build, we reported a commit ID. Yeah. So this is kind of a choice. You can do either. I like to always use my commit IDs because then I have just really good parity from my source code through all of my tooling where I can look at. I actually use it for my Docker image tags. I always put my commit SHA on it so that if I look at a Docker image, within Codefresh, I can actually see what's running. I can click on the image. It'll take me, I can see what code was made. Yep. But barring that, even if I'm just looking in terminal or something, I can see, okay, well, here's the commit SHA. And now I can look it up. I can look it up if I need to. So good. That concludes our questions. So next steps, we're going to be publishing this, and you can share your screen again. Yep. To get started trying this with Codefresh, we do offer 120 builds a month for free. So you can go create a free Codefresh account, and you can do this whole demo on a free account.
That's what I did.
You did it on a free account. Yeah, Craig was like, can you give me like the special account? I said, no, just go create a free account.
Yeah, that's what kind of friend he is.
And for JFrog, I believe it's a free 30-day.
Correct. So we have a 30-day trial. You can either do it in the cloud or download it and run Artifactory wherever you want. And put here the URL for the challenge to go win this t-shirt. Basically walks you through the manual steps to do the same things. We'll get this content up there. I think we'll build out the things we described in terms of optimizing and then publish that in a GitHub repo so everybody can comment on that as well and take advantage of that. Yeah,
and so look for the blog post probably today with just links to the slides and the video. So if you want to send it on to colleagues so they can watch it. And then the code is already on GitHub, I believe. Oh no, the YAML isn't. So we'll put the YAML in today.
It's easy. I'll just commit the YAML.
Perfect. Okay, sweet. Well, with that, thank you very much, and we'll see you around.
Thanks, Dan. That was fun.
Thank you.